Welcome to www.happynumbers.org. Today's lesson is on the concept of probability, mathematical probability. Now we can define probability as probability is equal to the likelihood that an event will occur. The likelihood that an event will occur. Don't confuse the concept of mathematical probability with the word probably, like we use in everyday language, like, well, my friend and I probably will go to the movies tonight. So that means most likely we'll go to the movies. But in terms of probability theory, probability is the mathematical likelihood that an event will occur. And we use probabilities all the time. You'll hear the weather person say, well, there's be a 60% chance of rain. Well, that's a probability statement. It's saying 60%, as we recall, 60% is really, if we change it to a decimal, 60 hundredths. So they're saying 60% of the time is a chance of 60% it will rain. And of course, if there's a 60% chance that it'll rain, there's then a 40% chance that it will not rain. But those are probability statements. And we use probability all the time, especially in games of chance, in dice, in cards, and in mathematics. So we're going to learn how to work with probability and how to understand probability theory. Pardon me. Probability is always reported numerically as a number between 0 and 1. A number between 0 and 1. If an event has 0 probability, if the probability is 0, this is usually how probability is written, by the way. Probability is the P. Probability of an event happening is 0. It means that the event never happens. The event never happens. If the probability of an event happening is 1, that means the event will always happen under every circumstance. But generally, probability is reported as a decimal number between 0 and 1. Probability can never be less than 0, can never be a negative number, and it can never be greater than 1. It's always between 0 and 1. Let's take just a simple look at this. Oh, well, before the way we calculate the probability mathematically is it's a ratio or a fraction. The denominator of the fraction is the total possible outcomes. Total possible outcomes, and the top part is the desired number of outcomes. And I'll explain this. Let's take, we want to know what is the probability if we flip a coin that we will get a head. We will get a heads. And the way we can write that, probability will have H stand for heads. Probability of flipping one coin and having it land on the head. Well, to figure that out, we want to know the bottom part of the fraction is the total possible outcomes. Well, I could get a head or I could get a tail. So the total possible outcomes are 2. But the top part of the fraction is the desired number of outcomes. Well, the desired number is I want to get a head. And if I get a head, there's only one outcome, one desired outcome. So the probability of flipping a coin one time and getting a head is 1 over 2, the fraction 1 over 2. Let me just put that over here. 1 over 2, and we know 1/2 is 0.50, or 50 hundredths. So the probability of flipping a coin and having it land on the head is, probability of getting ahead is total number of possible outcomes, which is 2, divided into the desired number of outcomes, which is 1, because it's ahead. Well, what would be if we wanted the probability of getting a tail? Well, the total number of outcomes, head and tail, so it's 2. Desired outcomes is 1. So the probability of getting a tail is exactly the same as the probability of getting a head. Good, well, let's take a look at some problems then. And I'm going to put this here. Probability equals total number of possible outcomes over desired, or the number of outcomes that we're looking for. Let's take something like this. I'm not a very good artist, so bear with me. But let's make believe this is a spinner. This is the arrow and it'll spin around. And we have the numbers 1, 2, 3, 4, 5, and 6. Well, suppose we wanted to know what is the probability of getting a 1? What is the probability of spinning the spinner one time and having it land on the number 1? Well, we have to then have the total number of possible outcomes. Well, it could land on 1, or 2, or 3, or 4, or 5, or 6. So there are 6 possible outcomes. And what is the probability of it just being on the 1? Well, just 1, that's our desired outcome, is 1. So the probability is 1/6. And if I wanted to change that into a decimal, I'd have to divide 6 into 1.00, let's say. Put our decimal here. 6 goes into 1, can't, but 6 can go into 10 one time. 1 times 6 is 6, and we'll get 4, bring down to 0. 6 goes into 40 6 times, and so we have a remainder, that would be 36. We have a remainder of 4. So, and 4 6 would be 16, and we'd reduce this to 2/3. So the probability then, 16 and 2/3, the probability of spinning and having it land on the number 1 is 16 and 2/3, or the fraction 1/6. All right, let's take a look here. Suppose we wanted to know the probability of spinning this arrow, spinning it, and having it land on an even number. So what is the probability, and we'll use E for even, of spinning the arrow one time and having it land on an even number? Well, what are the total possible outcomes? Well, we know there are 6. We can put 6 down. Now, the desired outcome we're looking for is it's an even number. Well, we have 2 is an even number, so that's 2, and 4, and 6. So there are 3 desired outcomes. So the probability of spinning this once and having it land on an even number is 3/6, or the probability of even is 3/6 is equal to 1/2, which is 50/100ths. Good. Let's consider this. What is the probability of spinning this arrow one time and having it not land on 1? Not land on 1. So this is written this way. The probability of not 1. Whoa, okay, now our total outcomes are exactly the same. It's still 6. 1, 2, 3, 4, 5, 6. But what is the probability of it not landing on 1? Well, if it lands on 2, 3, 4, 5, or 6, it's not landing on 1. So that's 1, 2, 3, 4, 5. So the probability of not 1 is 5/6. 5 is our desired outcome because we don't want it to land on 1. So we have 2, 3, 4, 5, or 6. So we have 1, 2, 3, 4, 5. So 5 over the total number of outcomes. And of course we could divide 6 into, to get our decimal, 6 would go into that 8 times, which would be 48. Bring down that, and we get 0. 6 goes into 20 3 times, that gives us 18, and then we'd have 2 left over. And we'd have 2 6 as a fraction, and if we reduce that, it's 1/3. So it would be, the probability of not landing on 1 would be 83 1/3 hundredths. Excellent. Excellent. Well, let's do a quick review here. Probability is a mathematical statement about the likelihood that an event will happen. Probability is always a number that is between 0 and 1. It's never greater than 1. It's never less than 0. If the probability of an event is 0, that means the event will never happen. The event will never happen. If the probability of an event is 1, that means the event will always happen. Will happen all the time. And to compute probability, we have our desired outcome the outcome that we're looking to happen over the total possible outcomes. And let's take the example of flipping a coin. Let's have a flip a coin one time. What is the probability of, whoops, my bad, probability of getting a head? Well, if I flip a coin, the total possible outcomes are 2. The desired outcome that I want is a head, which is 1, so the probability is 1/2, which is equal to 50 hundredths. And that is basically an introduction to probability. Next lesson, we'll actually do some more specific problems in calculating probability. Oh, and there's my time. Well, great. Thank you very much.